Let's talk about a concept that is quietly becoming the secret sauce in AI development. It's called harness engineering. And honestly, it's the real reason why some AI agents are just unbelievably reliable and others, well, they just fall flat. You know the feeling, right? You build an AI agent, you give it a complex task, and you just watch it work its magic. It feels like you're living in the future. But then you try to run it a second time, or maybe on a slightly different problem, and poof, it just breaks. Why does that happen? I mean, the dream, the expectation is that you'll have this brilliant autonomous assistant that just handles complex stuff for you. But the reality, more often than not, is an agent that gets totally confused, starts repeating itself in a loop, or just completely forgets its own mission halfway through, and it is incredibly frustrating. Now, here's the twist. Your first instinct might be, okay, I just need a bigger, smarter model. But what the top developers are figuring out is that the model itself isn't always the problem. The real key to success, the thing that makes or breaks an agent, is the entire system you build around it. So to really get a handle on this, we need to take a quick look at how we got here. It's really been a journey in three main stages. We started out with prompt engineering, which is what most of us know. Then things got a little more sophisticated with context engineering, and that has led us to where we are today with harness engineering, each one of these levels up from the last. So let's break them down. Okay, first up, prompt engineering. This is ground zero. It's the art of writing that perfect set of instructions, the prompt, to get the model to give you what you want in the format you want it. Basically, it stops the AI from just, rambling on aimlessly. The best way to think about this whole evolution is to imagine you're onboarding a new employee. So prompt engineering, that's like giving that new hire a super clear, very detailed to-do list for one single task. You're telling them exactly what to do. But hey, a simple to-do list isn't always enough, right? And that's where context engineering comes in. The model needs background info to do a good job, but its short-term memory, that context window, is tiny. So context engineering is the whole game of feeding it the right information at the right time without completely overwhelming it. So back to our new employee, this is like handing them the entire project folder. It's got the client's history, all the product specs, notes from past meetings, all the crucial background stuff they need to actually understand the why behind the what you asked them to do. And that leads us to the main event, harness engineering. This is the whole shebang. It goes way beyond just instructions and background files. We're talking about building a complete support system, a harness that guides, checks, and even course corrects the AI's entire process from start to finish. And to wrap up our analogy, the harness is literally everything else that makes an employee successful. It's their manager, the project plan with checklists, the quality assurance team that double-checks their work, and even the company playbook for what to do when things go wrong. It's the entire support structure. Okay, so this harness idea sounds great, but what is it actually made of? Well, it's not one single thing. It's really a system of a few key layers all working together to keep the AI on the rails. A really solid harness has four essential layers that do all the work. You've got the memory layer, the execution layer, the feedback layer, and the orchestration layer, and each one has a critical job to do. Let's break it down real simple. The memory layer is what stops the agent from getting amnesia. It holds on to the main goal. The execution layer gives the agent hands, the actual tools to interact with files, APIs, and the command line. The feedback layer is like an inner critic, a self-correction loop that learns from errors. And finally, orchestration is the master project manager, breaking down a huge, scary goal into tiny, bite-sized steps. Now, this all sounds great in theory, but is anyone actually doing this? Oh yeah. Let's take a look at how the biggest names in AI are already using these principles to build their most powerful agents. Okay, check out this super clever trick from Anthropic. They saw that after running for a long time, their agents would get bogged down as their context window filled up. So instead of trying to make the AI summarize all that old info, they did something kind of radical, a context restart. It's like when your computer gets slow and you just reboot it. A fresh, clean agent just takes over. That is a brilliant harness strategy. And hey, it's not like everyone gets this right the first time. Even OpenAI fell into this trap. Originally, they tried to stuff all the rules and instructions into one massive file called agent.md. But they quickly found out that just dumping a 500-page manual on the model all at once was just confusing it. So what did they do? They built a harness. They broke that monster file into a neatly organized directory of smaller files. Now there's a simple index file that's like a table of contents. The agent reads that first, figures out exactly what it needs for the one step it's on, and then pulls in only that specific file. It's a just-in-time information system. So, after all that engineering, what's the real impact? Does it really move the needle? Well, the numbers kind of speak for themselves. And here is the absolute kicker. One team was struggling with an agent that was succeeding less than 70% of the time. They were completely stuck. So they stopped tweaking the model, and instead they focused on building a proper harness around it. And the success rate rocketed to over 95%. Let me just say that again. They were using the exact same model. The only thing that changed was the system around it. That's a game changer. This all leads to a really profound shift in how we should think about the future of building software. It's changing what the job of a developer is actually going to be. If you take just one thing away today, let it be this simple equation. A truly successful AI agent is not just the model. It's the model plus the harness. The harness isn't optional. It's the part that actually delivers the reliable performance. And this is why it all matters so much. The role of the programmer is changing fast. It's becoming less about hammering out thousands of lines of code and way more about being the architect who designs these intelligent, resilient systems, these harnesses that guide the models who will do a lot of the coding for us. Which leaves us with a final big question to think about. As the AI models themselves get better and better at writing raw code, could it be that the most important skill for the programmer of the future isn't actually coding, but the art and science of building the perfect harness?